the reactant that could produce the least amount of product is the limiting reactant. I'm going to teach you how to find the limiting reactant, and that is just what it sounds like. That is the reactant that will limit the amount of product we can make in a reaction. So I have a couple things I need you to make a note of. If I want you to think in terms of the one that runs out first. Okay, have you ever been making peanut butter and jelly, and you're not going to have exactly the right amount of peanut butter and jelly to make sandwiches, right? One is going to run out before the other. That's the limiting reactant. It will be completely consumed in a reaction. There will be another reactant probably left over. So the limiting reactant is the one that will produce the least amount of products. And so I want to show you some examples of this. First of all, I've got a given amount of reactants, and this is how you know that you will need to do limiting reactant. If you're given quantities of all of your reactants, you need to find limiting reactant. So let me just show you. Can you tell which one would limit this reaction? Is it oxygen because we just have 1 mole? Maybe, maybe not. That's not why. So let me show you what happens in this reaction. When we're done, we have 2 water molecules and we have a bunch of hydrogen left over. So guess what the limiting reactant was? In this reaction, oxygen was the limiting reactant, and I like to abbreviate LR for limiting reactant. And then the oxygen, do you notice we had some left over? This is what we call excess. Okay, now why won't the hydrogen react and make product? Well, the reaction has stopped because we've run out of oxygen. Once the limiting reactant is used up, it's the end of the reaction. Nothing else is going to happen. So let's do an example of this. And here is what we need to do. One of the things, you may have heard a phrase, you can't compare apples and oranges. Well, that's true in chemistry too. We can only compare like things. We can't compare 6 moles of hydrogen to 1 mole of oxygen because those are apples and oranges. We need to compare like terms. So let's keep that in mind when we work this problem. So here's our example again. And what I want to do is find the amount of product. Now, what's my product? My product is water. So I want to start with those 2 given reactants and go to moles of product. So I'm just going to need to use a couple mole ratios. So I'm going to do it for hydrogen. I'm going to do the same thing for oxygen. Okay, so let's use a mole ratio of hydrogen to moles of water. Okay, the coefficients are both 2. So that amount of hydrogen is capable of producing 6 moles of hydrogen. Now the oxygen, if we convert that to water, 2 moles of water for 1 mole of oxygen is capable of only producing 2 moles of water. And I want you to write a big fat or in between. Okay, so we are comparing 6 moles. One of our reactants can produce 6 moles. The other reactant can only produce 2 moles. And so oxygen is my limiting reactant. Why? It's going to run out when we get to 2 moles of water. And that's exactly what I showed you in this picture. And then the hydrogen is going to be present in excess. All right, so let's do another problem. I've got grams of everything. I've got grams of aluminum and grams of oxygen. So we're going to find the limiting reactant first, and then we're going to do a couple more things. So first of all, just start with your quantities. And what we're going to do is find the moles of product that each one can produce. Okay? So I'm in grams, and I'm trying to get to moles of product. So first step would be convert to moles. Okay? Once I get to moles of aluminum, I can use my fancy new mole ratio to convert to moles of aluminum oxide. Okay? And let's go ahead and pop some numbers in here. I'm going to go ahead and set up my oxygen, and then we'll fill in the numbers. So 1 mole of oxygen. Okay, and then we're going to trade in moles of oxygen to moles of aluminum oxide. Okay, so I'm going to calculate, this is how much aluminum oxide each of them can produce. Now go to the periodic table. I'm going to pick off the molar masses. Okay, and then oxygen is diatomic, so there's 2 times 16. Okay, now I'm going to go up to the reaction. I want to highlight these coefficients just so you remember where the mole ratios come from. So the coefficient of aluminum oxide is a 2. The coefficient of aluminum is 4, and oxygen is 3. That's it. Okay, those coefficients drop right in there, and those are your mole ratios. All right, now let's just check our units. Grams, grams, moles, moles. Left with this. Grams, grams, moles, moles. Left with this. Okay, and then we go to the calculator once, and we're going to calculate these two numbers. Hang on to your sig figs, 0.463 and 0.490. Now, this is a very dangerous thing. I have 2 quantities with the same unit on my paper, and I want to write or. I always write or, because can they both happen? No. The reactant, one reactant will produce the least amount of product, and that's my limiting reactant. So pick the smaller of the 2 and then cross out the other one, okay? Because it can't happen. The limiting reactant is the one that produced the least amount of product. So the limiting reactant in this case is aluminum, because that quantity produced the least amount of product. All right, the next thing we want to do is talk about excess. Okay, and so how much excess reactant is going to be left over? Well, it's going to be oxygen. All right, so first I want you to find out how much is needed. So let's say how much oxygen is needed, all right, to give us that quantity right here. Okay, that's the amount of product we should produce. And so I'm going to start with the 0.463 moles of aluminum oxide. All right, and just do a mole ratio here. Get rid of moles of aluminum oxide and go to moles of oxygen. And then we'll trade in moles of oxygen for grams of oxygen. Okay, mole ratio is going to pick them off the reaction. So 3 and 2, those are your coefficients. And then molar mass of oxygen is 32. Okay, and when we work our units here, everything will cancel and we will get grams of oxygen. All right, so the answer to this little calculation is, let's see, 22.2 grams of oxygen. And I'm going to write the word needed because we have another number right here. Guess what we have here? We were given, I'll say, available. We had 23.5 grams available and we only needed 22.2. And so I'll subtract, we're going to get 1.3 grams of oxygen are going to be left over, or we would call that excess. Okay, so to find the amount of excess, we found out how much we needed. And when I say needed, that is to go with that limiting reactant. Where did that number of moles come from? That was how much product the limiting reactant, the aluminum, would produce. Okay, and then one last thing let's do on this problem is how much aluminum oxide will we get? Well, we've already actually found, way back here, we found moles right here. We found 0.463 moles is all we can make because the aluminum will run out. So let's start with that. 0.463 moles of aluminum oxide. And then let's just use molar mass to get to grams. Okay, and the molar mass of aluminum oxide, I'm going to add up 2 aluminums plus 3 oxygens, and I get 101.6 47.96 grams. Okay, and then when we multiply, moles cancel, and we get 47.2 grams of aluminum oxide. Now, these problems, let me just warn you, they seem a little fancy, a little complicated. We've only used two tools. We've used molar mass, which is old. We've done that lots of times. Here's one right here, molar mass. We've used molar mass to go back and forth between grams and moles. And then we've used our new friend, the mole ratio, like this. And that comes from the balanced chemical equation. So give yourself a little time and a lot of practice to do these types of stoichiometry problems. It is very important for the future in chemistry.